folks. I'm really excited to share this conversation that I have with Ev Kontsevoy, who is the CEO of Teleport. This is actually a really interesting conversation. Before Teleport was called Teleport, it was called Gravitational. They had two products. One product was called Gravity, the other was called Teleport. Gravity was Replicated's first and really still only direct competitor. So we went head to head in a lot of deals. We were true competitors for maybe like 5 or 6 years until they eventually saw a lot of success with Teleport around the pandemic and decided to go all in on that project. And they've had a lot of success since then. But Ev and I talk about that. This is the first time we've ever actually had a conversation more than like 5 minutes at a conference. So, it's us getting into that, what competing was like over some deals, some things that drove different competition. We talk a lot about just like what competition means to startups. I think Ev has some really interesting insights there. We also get into, his thesis around what it really takes to do sales well and sort of what that means within a buying group. We talk about like the overall identity space and authorization and, what Teleport's product is doing, how it affects the future for AI agents and AI workloads overall. It's just a really, really interesting conversation. Ev, is a two-time founder, had created a company called Mailgun, which is still wildly successful. They sold that to Rackspace. It's a really fun conversation, and I'm glad that I was able to share this first deep conversation with everyone that's listening. So thank you so much. Have fun. All right, Ev, thank you so much for joining me.
Thanks for having me.
I'm so excited to have this conversation. As listeners will find out, hopefully throughout this conversation, we actually competed head to head for some number of years with Replicated and, initially what Teleport was called, or the company was called Gravitational. So should be fun.
Yes. It's actually a very interesting topic that I think like how tech CEOs who tend to be competitive, ambitious people, how they treat competition generally, like like even mentally, like how much competition is, like how much is too much, like what happens if you don't have any competitors. So it's a really interesting topic, I think, to explore.
Yeah, I still remember when you got like this series, I would say Series A funding from Kleiner. I like heard through the grapevine that that you had gotten funded, and Kleiner was doing the round, and it was like right before like KubeCon North America, and I was just like, we need to launch this next product before they get that funding announcement out and like it just like it like pushed me so hard to like really go. It's just funny how those things work, right?
Yeah. So my view on competition has actually evolved over the years. So when I was younger, I was just I would actually get kind of crushed when I hear that, like, my competitors raised more money or they landed like a huge customer. I think it's understandable, just like human emotions. Like we feel like we're failing if competitors doing better. But then what I learned over the years is that your competitors actually, they're your natural friends, not your natural enemies. And friends in the sense that we share the same dream.
Yeah.
Which is kind of interesting. Like you start a company because you're unhappy about the state of the present. You want future to be better, but better in a way that you like. So guess who else likes the future to be exact same way? Exactly. So yeah, like after that, it became much easier for me to compete because now we're like basically two teams that are kind of rowing in the same direction. And it helped me too to be kind of mentally more well adjusted, I guess.
Sure.
Because startup running a company is stressful, so that reduced amount of stress that I was dealing with.
Yeah, no, that makes sense. I always try, and even still today, I just don't think about competition that much because I'm like, it's funny. This is like embarrassing to say, but I often like think of myself more as like an artist than anything else. Right. And I'm like, I'm like creating the art, the thing that's in my mind, right? I'm a builder. And so I'm like, I want like an almost unadulterated view of, what I'm trying to create and the vision that I have and not like somebody else's thing. And I don't want to get pulled by them, but I don't know. So I've never really been that bothered by competition, but occasionally, something happens that would like kind of light a little bit of a fire for me. So
Yeah, yeah, and you do have responsibilities. Like imagine you having kind of all hands meeting, and like all these people who work at your company, they look up at you and they want to hear your thoughts. Like, hey, like this competitor just raised a bunch of money or did something else that you need to share your opinion with the team. So that's kind of where stress is coming from. Was for me, but
that's a
yeah,
great point.
yeah.
Yeah, that
Or you bored your investor is like, hey, like what do you think about that? How did you allow that to happen? So it's easy to be stressed out.
yeah, no, that point about like the team gets more concerned about it, I think is a really great point, and kind of managing team psychology, right? And like because they don't all have the same psychology that you or I might, and and they're seeing something that's competitive.
Mm-hmm.
And I don't know. I mean, like, how did you? Or are there any times where, like, a competitor did something that really kind of lit a fire, or changed how you saw things, or made you go one way or the other? Like, how have you kind of handled those competitive nature? The competitive.
Let's use an example. So there was a prospect that we lost to you, actually.
Okay.
So we were kind of shocked that, oh, like Replicated got it. And because I'm an engineer, maybe, I immediately felt that something's wrong with the product. It
Hmm.
was like, hey, there is another tech company that evaluated our solution. They evaluated Replicated and they felt, by the way, I'm assuming the audience knows what Replicated is about.
Yeah.
Okay, so yeah, we all help SaaS companies to deploy their software as a service into on-prem environments. And in that particular situation, yeah, it just felt really heavy. It's like we worked really hard for a couple of years. We felt that we solved our like all these like really challenging problems in a compelling, kind of academically correct way.
Sure.
And then somehow these companies are apparently better. Like, what did we miss? So that was really hard. But what
Hmm.
happens then is like you evolve and you realize that product is only one of several components that are involved in enterprise sale. We could talk about this maybe more broadly, how
Yeah.
software is being acquired in the enterprise. But so that was an invitation to basically expand my horizon beyond product and product only, and look
Hmm.
at things like how you're positioning it, like how you communicate your value. Because when you say like we help you deploy software on prem, okay, fine, but what do you mean? Like, do you do
Right.
like are you like just copying, you know, bits over the internet? But you could use like a secure copy for that. So that was the moment. It was like invitation to learn, like more
Hmm.
about the world, how it works, what motivates people, who do you sell to. Like for me, like my previous company was called Mailgun. By the way, that's another interesting story about the competition that maybe we can go back to. But so that was kind of self-service, high-volume
Yeah.
transactional
Of course.
business. So we had like a web form on our website. You go sign up. There's a pricing calculator. You use your credit card, and then you don't have to meet a customer. So I never gotten that education. And that
Hmm.
example with Replicated beating us when we were trying to close that deal with a company in Seattle. Maybe you even remember
Yeah.
who that
Sure.
was.
Oh yeah.
So that was a kind of opening act for me to get street smart about how enterprise buys software generally. And I think we've gotten better since then, far better.
Yeah, if it makes you feel any better, eventually they churned off of us and went to something else. So that was a sad moment for us too. So
That's another learning moment for you, right? So
yeah, exactly. Yeah, yeah. That was. I think our learning there was that So it's this, if you're thinking about it correctly, I think it was this big kind of like early AI company that. Oh shit! It was UiPath. Is what I'm thinking about. Is that right?
okay, you said it, not me.
Yeah, great. So it was UiPath. And yeah, that was a really intense sale, actually. And it was actually at the moment where Replicated we had just launched this product called COTS, which was pretty cool because it did two things. One, it like deployed into existing clusters. And then it also would deploy Kubernetes when the customer didn't have it. And that was like, we always position it as the full spectrum of customer
Mhm.
deployment. But that sale was a really intense one. And we had found really good product market fit then. And we had just started to scale it up and it was all kind of working. And actually they were quite successful with Replicated for some amount of time. But then eventually they needed 24/7 support, which we didn't have. We were like probably at that time when they wanted that, we were a 30-person team. We just didn't have that many people that could
Mhm.
support it. And we just, I think, told them no, that we weren't going to do that. And so they left for Rancher and they used Rancher, which had a much bigger support org and gave them that
Yeah.
support. It was a, and then it took them like years to wind down off of our products because our products were pretty sticky.
Yeah, yeah.
Um, but yeah, that was a lesson there, and eventually we had 24/7 support. So
Yep, yep.
what did you kind of learn from that process? Like what was your learning? It's more than just product. It's also kind of how you position everything else.
I think the lesson number one was that if you simply say what you do, that's not enough. So you
Mm,
say, we help software companies to deploy their solutions into customer premises. But there are multiple problems hidden behind that statement, and those problems, the solutions to those problems, are not equally valuable to the person you're selling to.
yeah.
So some people hear that statement and they would just, simply because of their title and responsibilities, they would be like, oh, so you help us count how many licenses they're using?
Mm,
Other people will say like, oh, and you help us do like software upgrades remotely and securely. And someone else will say like, oh, you're going to help us with like remote support because now we have visibility into what's going on. Like you see like completely different angles.
yeah.
And it's impossible for you, particularly in the early stage, to do all of that
Hmm.
or all of that well. So then when you are presenting your solution, you really need to articulate the unique value that you're bringing, and then you're explicitly stating what you don't do.
Mm,
So, and look, it's a never ending process because you can only become better by practicing because it's impossible to guess these things. It's like back then, I never even met anyone who worked like at a big financial institution. So if you close like several deals to large tech companies, like Snowflake and Dropbox, like people like that, so they have completely different concerns and they have very different backgrounds from someone like Wells Fargo or JPMC or I don't know like BlackRock. So you only learn to tailor your message and your value proposition to markets you're serving as you're doing it, which basically means there are plenty of opportunity to be disappointed because initially you will always be bad. Like try to go sell your software to like a manufacturing company. You're
yeah.
going to be prepared to be surprised by what kind of questions you're going to get during that cycle. So that's basically the kind of lessons that we were learning back then, like when we were presenting our solution. It's actually, maybe it's worth explaining to folks who are familiar with Replicated what happened to Gravity, our competing solution, and why
Yeah.
we don't do that anymore. So
And I
just
also maybe even rewind. I think the vision you have for Gravity was also a bigger vision that we ever had for Replicated. Like you Replicated was just about helping software get deployed into these remote environments. I think I've listened to you to talk about the vision you had for Gravity as like this operating system, for the cloud, and it's like it's a much bigger vision and really interesting. And so I think you can tell the whole story about it. And then obviously I want to hear more about Teleport as well. But yeah,
yeah, let's talk about this. So isn't it an interesting question to ask ourselves why deploying software in the cloud is so hard? Because back in the day, before we had this massive cloud environments, and we were, again, it depends on your age, of course. If you just entered the field, you probably don't.
a little history lesson for you. Yeah,
Exactly. It's like
yeah,
back in the day before
yeah.
software, like people used to run software on like individual computers, like on their desktops, or like a company might have like a giant server in the basement, and you would put like Oracle on it or something.
Right.
So back then, deployment was not a problem. Like sometimes it's as simple as drag and drop. It's just drag and drop file, and you click on it and it
Run it.
runs. Like even today, when you like deploying software from like Apple App Store onto your phone or your laptop, it's actually kind of trivial.
Sure.
Like, why is it not trivial in a data center? And some people will say, like, "Oh, it's because of scale. It's because of the complexity." But hey, you know what? Like, what's happening on your laptop is actually also insanely complicated.
Hmm.
Your laptop has millions of lines of code running on it
Sure.
with like dozens and hundreds of processes and actually microservices, I would
Yeah.
even say. And yeah, it's still trivial. And the reason for that is the operating system. So it provides just the right amount of abstraction that allows you not to think about things like users and authentication or like which like storage management or like all of that is taken care of.
Mm.
But we don't have that concept in the enterprise.
Mm.
When I say in the enterprise now, I basically mean cloud
Sure.
environments.
Yeah.
So if you look at any company that is building and running web applications at scale, or not even like at scale, just web apps, period, they always have a SRE team or platform team or cloud team or foundation team, but you know who I'm talking about.
Sure.
So these are engineering teams that are not building the actual software, but they're building and maintaining these environments. Those teams are actually quite sizable.
Yeah.
Like some companies even say it's almost as big as their kind of core software engineering team. And you ask yourself, what do they do? And I would say what they do is they develop and maintain a custom operating system for the environment of their company. So you could pick any tech company you want, like, Snowflake, Dropbox, Twilio, like anybody. So like GitHub, they have DevOps teams.
Yep.
Those DevOps teams, they develop these platforms that the rest of the company runs on. So the question is, why do we keep developing custom operating systems? Like every single company out there built their own custom OS.
Yeah.
And I like to look back at the history. And yes, indeed, that's how actually it used to be. Like way before IBM mainframes, like early computers, before they roll out with the 360 system, you would buy a computer and you would basically build your own software from scratch for it. There was no standardization. So that's actually what made IBM huge, is that they made programming kind of portable. So you could build an application, run it on a machine, then you get a new version of the machine, and you just move your application to that other machine and it will just work. And I just feel that because history is evolving on a spiral, right? We are going to inevitably end up with someone developing an operating system for the cloud. I was hoping Kubernetes would be it. Maybe it will. It's hard to tell, but so that is what the idea of Gravity was coming from. So even though, like at the time, I was thinking, like, if we try to build an operating system for cloud software, it would be incredibly hard to get it to market because you have to be huge. It's not the kind of project that a startup can take on. So then you have to develop this kind of a path between now and this bright future. So you need to have some kind of intermediate products that you can launch along the way. And it just so happened that helping companies deploy something on-prem could be the first use case that we can go after, with these hopes that eventually, it's kind of like Tesla. First you build like a roadster,
Sure.
and you use that revenue to fund your next project. And then eventually, like 10, 15 years later, you become this giant company. So we were using on-prem deployments as this kind of stepping stone towards developing this operating system. But what happened then was that it kind of happened the exact same way. So when we were people looking at Gravity, and it's just because of the first few customers and use cases that we had at the time, security was extremely important.
Yeah.
So like the one thing that Gravity had going for it, that it had incredibly well implemented an identity management systems within a product. And it was architected as a Golang library. It was called Teleport. But the basic idea is that if you have a computer, which is a computing environment in this case. So from a Gravity perspective, and I guess from replicated perspective, so you have an environment. So that's your deployment target.
Sure.
So you need to bring everything that will be running there. You need to have like a Kubernetes cluster. You need to have like a couple of databases, like web servers, like microservices, like all this kind of complexity. But all of them need remote access and remote management. So you have this idea of a user account, and it exists in MySQL, it exists in Postgres, it exists for Linux, it exists for Kubernetes. So there's kind of fragmentation of identity that's going on within an environment. And it was extremely important for us in the early days, again, because of customers that were in front of us. So they were influencing our roadmap. We very quickly realized that we need to have a unified identity layer on that environment. So if I am Ev and I need to remotely access any of these components like Linux, MySQL, Kubernetes, or Grafana, whatever, I need to have a single way to log in, and I will be me when I touch any of these things. So if you think about it, that's exactly what operating system does. Like on your Mac, you have an identity system. So all the users, they have user IDs. All applications, they have PIDs, process IDs.
Right.
So it's impossible to be anonymous on a computer. And that was the exact same requirement we had for Gravity. And when we started acquiring more visibility, like people started to see what we're doing, so that identity management component started to become more appealing to people. And they said, hey, I don't have a use case to deploy anything on-prem, but I really like the way how you guys do kind of SSH at scale, for example. So that is when we realized that we now have a bigger market, like outside of on-prem deployments, if we just focus on identity management. So that's kind of what happened there.
Oh, it's really interesting. And so just for my knowledge, when you said like, remote access, right? Were you thinking this is like the vendor is getting remote access to the cluster or to the environment, or is it the enterprise IT admin that's like getting remote access to the environment? Like who is
Actually, neither.
Okay.
So we were heavily influenced by what we call now MSP use case, managed service provider. In
Oh
this
yeah.
example, you have some, I'm hesitating using names of real companies, but
Yeah.
let's just imagine you have company A that builds software. And then company B wants to use that software. But because they don't have their own operations team, they work with a managed service provider. And that managed service provider manages software for them. So they're kind of this triangle. There are three companies involved.
Right. Yeah.
Again, one is a vendor who makes software,
Right.
another is consumer, company that needs to consume that software, and a third company kind of manages that software, which is actually happens all the time if you look at like government, if you sell into federal use cases, it happens all the time. So how do you manage that triangle of three different identities? So we saw that as like the problem number one to solve, almost like
Mm.
problem number zero. So
Mm.
Teleport is actually older than Gravity
Oh, interesting.
because the very few prospects we had at the time, they had that requirement that we need to manage this MSP triangle. We realized that identity management is even more important for us for that prospect than actual process of like software deployment, like moving software from A to B,
Yeah.
because it's actually really complicated. So if you're an MSP and you work and you are an engineer as an MSP, so you have multiple customers or clients, so you need to go from one environment to another, but do you keep the same level of permissions?
Right.
It probably depends on what kind of customer you are servicing. So because some customers will say like, we want engineers who are accessing our environments to be, I don't know, to have like security clearance or to be tested for drugs and whatnot. Like they have all kinds of requirements. So you have then the need to dynamically drop or elevate privileges based on which tenant you're servicing.
Mm.
So you see, it almost like it's almost an accident that we ended up being an identity management company super early
Yeah.
without realizing it. But didn't realize it for a very long time. And the forcing function that made us realize that the most of the value that Gravity brings is identity management. It was COVID. Because
Right.
COVID forced everyone to reevaluate their kind of identity story.
Mm.
COVID accelerated frequency of identity attacks. So that really what brought so much attention to our solution, because it's, I will say something that security people will just find preposterous, but we do have technology to make your infrastructure unhackable.
Mm.
So that's what kind of brought the spotlight on Teleport, and this is what allowed us to kind of abandon kind of on-prem deployment use case.
Yeah. Okay. So were you selling directly to the MSPs that they were like your customer, or they were just really involved in your relationship with vendors? What was the?
So ironically, we didn't close any deals with MSPs with Gravity. See, that's kind of how funny these things are. Like in the early days when we had no solution, we found
Yeah.
more kind of interest from MSPs. But when it
Mm.
was actually ready to deploy, then apparently it was like SaaS companies, like tech companies, basically exact same kind of companies that you sell
Sure.
and replicate it to. That's where we found success. So which is really weird. So we
Yeah.
built this amazing capability that actual customers that we were targeting didn't buy in the end, but it brought us a bunch of other interest from other groups of prospects who found that more appealing.
Yeah. And you kept developing Teleport. Was it like a separate project to begin with, or was it like,
Yes.
okay, so it was always a separate project?
Well, I'm assuming your audience is technical. So the one thing about like Golang is that it's a language and a ecosystem which is pretty good at packaging.
Yep.
So Gravity, and it still sits on GitHub. Anyone can go and take a look. It was always kind of neatly broken down into these kind of libraries. So we had like one library for like working with Docker containers, another like one for managing Kubernetes and so on and so forth. So Teleport was a library actually for
Mm.
managing access. And then when people started asking us questions like, hey, how does Gravity do this and that? all we did, and it actually took us very little time, I want to say maybe less than a week, we built command line tools that were just teleport only. It's basically, here is kind of access minus everything else. And I personally was even thinking, like, these are just examples of how you use teleport library. But then we just kept evolving, and eventually they just turn into, Linux daemon, CLI tools, and so on and so forth.
Oh,
So
interesting.
I just think it's, I guess the lesson here is when you design your solution early on, make it composable. So it would be easier then to retire components that are not as useful and easily integrate things that you're missing or missed in the early days.
Yeah. And then, okay, so from what I heard you say in some other podcasts, like you basically had Gravity and teleport maybe one or two engineers and was like half your revenue. And like
Yes.
you had like 9 engineers or something on 10 engineers on Gravity, and it was the other half. And it's like a lot more work. It's a lot harder. And so you were just like, oh, this is clearly, there's more pool here. It's maybe a better business. People are more willing to pay for it. So, and there's better growth here with teleport. So let's just make the pivot and go over.
I like listening to you when you say that, because it seems like a very obvious and easy decision, but it was actually hell in the
Yeah,
moment.
I'm sure.
Because the crazy thing was that we ended up having these two revenue streams, teleport
Yep.
and gravity. And at the time we didn't have venture investors, so it was just basically founders. So we
Mm.
made this agreement that we're going to keep watching like the revenue. Like once one product begins to outpace the other one, we're going to shut the other one down. It's easy to you say that, but then you start watching like one quarter, second quarter, and they're like going neck to neck, and you're like, damn, it's like you're rooting for one of your babies to die, right?
Yeah,
Because you're
yeah.
realizing that it's not sustainable. You cannot have two products at the same time. But you'd be like, you close one huge gravity deal, and it's like, oh, gravity, yeah, it's going to be our future. And teleport is just kind of limping along. And then next month you close like a really nice teleport deal, and it's like, and you're almost disappointed. But as I said, COVID created like a lot of clarity around that.
Mm,
So teleport sales became to outpace gravity quite significantly, and it was actually an easy decision. It
yeah,
took a while, but it was easy at the end.
yeah. It's and I mean, it was an interesting moment for me when you announced it, because I was like, again, we had been competing pretty much head to head for some number of years, not in every deal, but in some number of deals we'd see each other, and it was, like it was like, I guess this is good news that we no longer have this competitor, but like it's also like somebody exits the market, and to be honest, like the replicated and Gravity, like market is not an easy market. Like it's like
Yeah, yeah.
it is a you're like, I always say, you're cooking for chefs, because you're basically building software for other people who are building software, right?
Yeah,
They,
I like
they
that
like
analogy. Yeah.
have this high expectation of everything, and the ecosystem was moving so fast around Kubernetes and cloud native and Helm and all these other things. It was like you didn't know what was going to come next and where things were going to go, and we saw a lot of like kind of unique like architectures and people taking different angles and approaches, and it was like a kind of like, oh shit, like this is like a little bit different for this customer, a little bit different for that customer. It's all the same technology, but like somebody else wants something new. So I mean, it was, I think we were probably like, we were doubling year over year around that point, right? So like we were just growth, but we weren't doing much revenue at end of 2019. We were probably doing 3 million a year. You were probably somewhere in that range as well.
Yeah, yeah,
um,
actually feels right. That's right.
yeah,
Hmm.
somewhere around there, right? So like neither of us were behemoths, and but like, so I remember being like, oh, this is really interesting, like they're getting out of the market, and I was like, I guess it's good, but it's like, there's a little bit of like, okay, is grass greener over there, like where are they going?
But it's that sadness that I was talking about earlier,
Yeah,
because you feel like that's the moment where you can feel like I'm actually losing a partner there,
yeah,
because there
sure.
was someone else who really had this like similar vision. Yeah, definitely. Yeah, I feel you.
Yeah, it was an interesting moment. It's funny because you would think like a competitor leaves and you're like, ah, that's great, but you're a little like, oh, that's a little confusing. How should I feel? All right. So, what one thing that we kind of talked a little bit about before that you alluded to was this like kind of thesis you have around how enterprises buy. I wanted to like kind of dig in on that a little bit.
So Yeah, so prior to this, to the recording, we're talking about something that I just learned. So I cannot take credit for it. So I was having dinner with Bucky Moore from Lightspeed.
Sure.
So he's a venture. So he is a VC who discovered Teleport in the early days. And he shared this a bit of wisdom. He himself, I think, learned from someone also relatively recently. It's about how companies buy software. So, like the one naive approach to think about that I used to have when I was young is that companies have problems. Companies then go and buy solutions. That's just completely wrong.
Hmm.
Companies are just kind of vehicles, they're structures. They have no consciousness, they have no memory. It's people who have problems. So, you need to solve a problem for a specific person that you're selling to. So, therefore, when you are designing a solution to be sold into an enterprise, you need to have a very clear idea who's specifically going to buy it. And it's not just about the title, like, oh, we're building for VP engineering, they're going to buy it, or it's director of engineering, or someone in marketing. No, like you need to be very specific. It's like, it's a company where in engineering, for example, is not a cost center. So you even start with like describing like the team, the circumstances, the context in which that persona is living, because it's the context that creates problems. And then you try to design your solution to fit those specific problems. But then once you begin to learn is that the the person who has a problem that you're trying to solve might not have any money. So the solution then is to get budget from a person who owns the budget. So now it's like there are two people you need to consider: the person who has the problem you solve and the person who has the budget. So then so you take that into consideration. So which means that when you articulate the value of the product, or maybe that some product now needs to have some capabilities that will appeal to that person as well. So now you basically need to sell to two. Then you realize, oh, hold on a second, there's a third component here. Because the person who has the problem might not necessarily be the person who will actually be the user. Okay? So if we take let's just say you're building a better SSH server. So the person you're selling to is whoever is responsible for protecting servers, because they want like SSH to be awesome. But that person is not going to be like typing SSH on a keyboard every day. Okay? But yet you still need to please the actual end user. So now I have three people that you need to please. Okay?
Sure.
And then, particularly with larger enterprises too, you realize that there is another person, like a fourth one, who has the authority to buy. Apparently, it's not the same as having budget, and it's not the same as having a problem. And the observation is that if those four personas are four different people, you're not going to succeed, which is kind of paradoxical. So you might have a solution that solves the original problem in the most elegant and cost-effective way. But because every time you try to close a deal, you need to have four conversations with four different people, and all of them are super busy, and it always takes like weeks to schedule and reschedule. So your sales cycles will be long. The cost of acquiring customers is going to be high. So you just economically, that is not the kind of business that venture capital can effectively support. So then it means that you will not have access to cheap capital, and your competitors will just zip by you. So the solution then is you need to, I would even say it starts with product. You need to design your product in a way, and you need to communicate value in a way where those four personas are compressed down to one individual. So essentially, you stay away from products that require a buying committee of four and try to have it compressed ideally to just one person. So when people, because it explains what happened with Wiz, everyone is absolutely amazed by that success story. First of all, the product is great. It solves a real problem.
Sure.
But there are plenty of other products that seemingly great, okay? But the interesting thing about Wiz is that the person who buys Wiz and the person who has budget and the person who actually uses it and has authority is the exact same person. So that allows you to be extremely efficient. And that's where that hyper growth comes from. Again, having all four compressed into one, that's an ideal situation. It's not always possible, but definitely not four. So now as I'm kind of thinking about like in terms of this framework, and I wish I remembered who was the guy who originally kind of talked about it, because I do want to give credit. I really appreciate the elegance of it. So I'm trying to optimize Teleport to, like, our GTM needs to be that the buying committee should be no more than two people. We already know that most likely we will always have the separation between the user and the buyer,
Mm.
simply because teleport is a solution that engineers actually use, like practitioners,
Yeah.
because you need the identity for them, you need identities for laptops, you need identities for servers, for AI, for all kinds of things. So like exec's not going to do that. So unfortunately, that's already kind of baked into the product. We cannot really solve that. But now we are thinking about, if you identify accounts we should go be focused on and selling into, there needs to be account ideally where the person with pain, like basically risk management, and the person with budget and buying authority needs to be exact same person. And now when I look at my pipeline and like which deals are closing faster and which ones are slower, like once you see that correlation, it's impossible to unsee. Like
Yeah.
where it's one person, that's a really fast sales cycle. Like even like with a giant logo, I know it's like 60 days and you're done. It's a really large deal. But the situation where it's like three different people, like, oh, that's difficult. You're basically seeing like most time is spent, just even scheduling takes so much time because you
Yeah.
cannot get three in the same room. Like their calendars just don't
Yeah.
overlap. Like there's just no way. So there's a lesson there that I really appreciate. So thank you, Bucky, for sharing it with me.
Yeah, and it's actually interesting because I think about like if I boil it down, like partly explains why maybe it's easier to sell to like small kind of startups and these kind of companies,
Yes.
because it's like early on, it's like the CTO
Yep.
or like the CEO. So you're selling to one of those people, they might have all of those things, right?
Yes.
And then as the companies scale and you start to sell to bigger folks, and then then there's a book that I love called The Challenger Customer. It's the follow up to the Challenger Sale, and it's
Hmm.
really about this consensus buying, right? Because to your point, they make the point. Have you ever read this book?
No.
So they talk about this process of, they're like, you think selling software to four people is hard. Buying software when there's, 5.5 people in the room that have to all get aligned is even harder, right? So they're
Yes.
like, and it's like this interesting perspective of then how do you drive a consensus sale? What does that require?
But you
And
know what's, sorry for
yeah,
interrupting, like, but there is dark side to this too. Because if you think about what kind of problems exist out there and are worth solving, so there are some problems that just basically have no other solution. It basically means that the existing framework in which enterprises acquire software prevents certain types of products to be built in the first place. Because you will be forced to deal with four different people.
right. I mean, so their research will tell you that like the average buying group is actually 5.4 or something, right?
Oh,
So like
it's even worse.
most people are actually selling to like a pretty large buying group in general. And to your point, it almost certainly slows down sales cycles and slows down the process and gives you lower, conversion rates and all those things. So I think maybe like if you can compress it to two people, you're probably going to end up with higher, conversion rates and faster sales cycles. But their point is like basically just most sales are just require more people to be bought in. And so that's, I think it's a good objective to try to like get as few people needed as
Yeah.
possible, but I don't know that it's like I feel like still in the world, a lot of people are going to sell to multiple people. So
I think there may be two lessons there. Lesson number one is that just think about this super early in your product design cycle.
sure.
Because when we were starting Gravity, we had security included. So for that reason, we had to address security concerns early on. But you could have easily designed a product. I don't know how you guys dealt it on replicated side, but if you don't even talk about security, then security person might not be involved.
Hmm.
So in our case, it was maybe beneficial because in the end, we found that person to be the most impressed with our solution.
Hmm.
But you really need to think about who those like 4 or 4.5 people are going to be. And the second lesson, which is maybe more applicable for people who already started companies and already have products, so then like that ship has sailed for them. At least it helps to include the org chart considerations into your kind of lead qualification. So,
Mm.
for example, at Teleport, I love asking prospects, this if I get a chance, of course. I ask him, who's responsible for security in your organization? So what I'm looking for is a couple of clarifying questions, because it means that they actually get me. And they will say, well, by security, do you mean like how do we secure our like AWS environment, or how do we secure our kind of office network and printers and stuff? So that's a very helpful clarification, because they're already realizing that those are very different security functions.
Yeah,
So
IT
then
security versus like application security.
so then you realize, oh, they have a security team within IT.
Yeah,
Okay. And then they also have security team within platform engineering.
right.
And I was like, okay, now you need to be really careful to only talk to the latter team. The latter team, not the former.
Sure.
Because first of all, you don't need additional cook in the kitchen.
Yeah,
And secondly, you could tailor your message to that one particular individual. So studying org charts of accounts you're trying to sell to, that is definitely helpful. But again, that only works if the average contract size allows you to do that.
sure.
Because if you're closing, I don't know, like $50 a month deals, you just
No,
simply like there is no way you're going to look at someone's org chart.
yeah.
So that's the second actionable thing that we started doing, and I think it's bearing fruit.
Yeah, I think, it is interesting. So like one of the things that almost a different approach to it. I've actually pushed our team to make sure that because we generally end up selling to director of DevOps and maybe a product person, and like CS has a little seat at the table and support has a seat at the table. There's like kind of the four people. The director of engineering for us or director of DevOps is kind of like the core buyer. But I've taken the approach of I want everybody at the table as soon as we can, so they all have a chance to say no. And they all know that there's like value that we're trying to bring them in our platform that like it's going to make this easier. And so my position has been like, get them to the table as early as possible, right? That way, like they're involved in the process. They feel like they can support it. And rather than like try to keep them out of it and then just try to do something that drives that consensus so they can all get aligned around like, oh yeah, this is valuable.
Do you allow me to play devil's advocate here?
Please.
So here's an alternative. Like, I'm not saying you should do that. It's really easy to say, like, to give like unsolicited advice, but it's much harder when you actually run a company. So imagine an alternative situation where you say, you know what? Let's take our product and double down on just one capability, which is license enforcement.
Sure.
And we just don't do anything else. Just like shrink the scope of what you can do. Then it probably means that the contract value is going to be smaller, because now there's like less of a benefit, right? So we're not going to help you take your software all the way to like on-prem with your customers. We're only going to help you like collect revenue and do license enforcement. Then your deal is going to be faster though, because you don't need to have all those four people in the room. Like support now doesn't matter. Sure. And it's really tricky to kind of calculate that trade-off. Do you go with a smaller product with kind of smaller scope, but highly optimized for a specific buyer? In this case, I'm not even sure who that would be. Maybe you probably know better. Who cares more about kind of licensing on a buying committee? So at least it's helpful to run these scenarios in your head. That's what we are kind of circling around here. Like there's no right or wrong answer, because it could be that if you gather 4 or 5 or 6, whatever people in a room, and you please all of them, but then you can charge, I don't know, like $10 million ARR from that account. Like, yeah, maybe it's worth it. It's going to take a year, but it's a pretty big contract. But sometimes it's just not worth it.
Yeah, totally agree. I mean, I think, generally if you find the ASPs anywhere, 100K or something, right? And you're selling to a group and then you expand and you plan for expansion, like you can, I think it's way better to be whiz, to your point. There's an advantage in being whiz and having, and if you can really find, I'm sure they have some amount of buying committee like that, because they're selling really big tickets. But if you can find where there's actual real benefit and the person who's buying it has the problem, is going to use it, like, and has the budget and authority, all those things, that's a great combination. Yeah.
Like maybe even simpler example to understand would be Salesforce. Again, I'm not old enough to remember how it was before, but think about like how like the original Salesforce product was sold. The buyer is VP sales.
Yep.
So that person has the problem. Like they need to keep track of what's happening with all the, like that person's going to use it actually also because they feel like how they have this reporting capabilities and so forth. Of course they have budget and of course they have authority. So your entire sale is like freaking, like just, again, ideal one meeting. How sweet would that be compared to Replicate It or Teleport or like most other companies?
Yeah, it is. I've always said, and it's funny, funny. I think there's a little bit of grass is greener sometimes. I always joke that like selling to revenue and RevOps teams is like they want to be the buyer that they like hope to someday encounter, right? Like, and so
Hmm.
they're they try to be responsive and they try to tell you what you need to do in the deal. So yeah, I think selling to those teams can be a little bit, yeah, they like to buy. So
Yeah. But if you put business aside and just think about quality of life in general, I would say that my favorite buyer is always in engineering,
oh
engineers.
yeah,
And the reason is I get to learn from them about their industry. So if you're talking to, I don't know, like some fintech company, they do high frequency trading, you learn how high frequency trading works.
sure,
So then you doing a deal with, I don't know, some kind of like government contractor that works at like on like military technology, and you learn like things about missiles, and then you learn about like oil and gas. And like that to me is just, I'm absolutely addicted to serving this kind of broader engineering community, because these
yeah,
people continuously educate me on how the world we live in operates. That's the most kind of appealing feeling in the world. So it probably means it's going to be like I'm going to be building products
yeah.
for other engineers my whole life. I'm just addicted to that feeling.
That makes sense. I mean, the other advantage I'll say is they generally give very good product feedback and things
Yeah.
that you hear and you're like, yeah, we should do that. Like, I can't, there's like so many meetings I've been in and I was like, yeah, I don't know why we didn't think of that yet. Like, that, you are absolutely right. We should do that right now. Right.
Yep, yep,
And
yep, yep.
that actually kind of, one other thing I wanted to bring up that reminded me of is this idea of like, okay, you get product feedback and you want to be able to implement it right away because you're like, it's just so good. I need to be able to
Yeah.
implement that. That's this concept that I'm pretty obsessed with that I call product velocity, right? So it's the ability to like hear something from a customer that you're like, obvious, no brainer, we should do it. And instead of like creating a Jira ticket and then like, maybe somebody, has to triage it and put it through the pipeline and then like, prioritize it, and it's like 6 months before anyone ever touches it. I think organizations with really amazing product velocity are able to like turn that ticket around in like 24 hours, right? And just get that out and be like, that's a no brainer, we should do it, and then you just do it, and there's a lot less process and there's a lot less like you know overhead or something happens. How do you think
Yes.
about do you think about product velocity? How do you think about driving that? Like, I think Wiz has it, I think like Cloudflare has it, but like who else has it, and like how do you think about it?
So first of all, thank you for suggesting. I'm stealing this term, product velocity. We're gonna use it internally more
Great.
frequently now, because we definitely describe the phenomena, but I don't think we ever had like a one specific term to
Sure.
in
Yeah.
it. So we'll do that. Thanks. And it feels to me that it's one of these problems that simply don't have like one single solution,
Hmm.
because you can ask yourself, where is that feedback coming from? And oftentimes there's a mismatch between your kind of expectations you're creating and what your product is actually delivering. And then they give you this feedback. So, oh, like this thing is missing. We expected it to be there. And
Hmm.
yes, it makes sense, especially in the very second when that feedback is delivered to you, because if they're good at communicating, they will make you feel like, yes, it's badly needed and it's no brainer. But then if that's obvious, how come you didn't think of that? And it goes back to this context that I was talking about earlier. Like we make decisions within the context. So it's mismatch of contexts. The context you're in when you design the capability, and the context of a customer when they suggest that to bridge that gap. So why did you allow those two contexts to diverge?
Hmm.
So when you're making a sale, when you're putting solution in front of someone, I would argue like first you need to invest into management of their expectations.
Sure. Yeah.
So that creates a separation between meeting their needs and just dreaming together. Because then once we make you happy, your product is like our product is in production, we solved your problem, everyone is happy, like come to our user conference or customer advisory board, whatever.
Sure.
Then we can dream about all these like wonderful things we could do. Like that is different though, because there's no money involved,
Sure.
because you solve the problem. But if that becomes a requirement suddenly, so that means you mismanage their expectations. So that's kind of one thing that we try to pay attention to,
Sure. I love that.
like
Yeah.
managing expectations of customer. And the second one is Let's call it a human capital problem. So I think we would all agree that every single employee that we bring into our companies, if every single employee was just like genius, super energetic, extremely creative, PhD of whatever, yeah, life would have been easier because we have superhumans working for us. But that's not the case. There are all kinds of people. Like people have families. People sometimes people get tired. Like humans are generally unreliable, and so it is our kind of role to enable them, to elevate them, and if to give them basically talent development is just as important as product development. Getting rid of
Mm,
underperformers on time. So all of that plays a huge role. And why am I mentioning this? It's because because when you shared this concept with me initially, I thought about like I think we're pretty good at implementing customer feedback, but then I realized that but there's this kind of long tail of feedback. So there are things that have like a lot of dollars attached to them. Oh, build us this capability and we're going to expand. And it's going to be like
sure.
extra million of ARR. Like, oh yeah, we're going to do this really quickly. Come on, like extra million of ARR. If you spend like, I don't know, 48 man hours of engineering, like, yeah, it's one of those no brainers. But then there's this kind of long tail of improvements that don't have direct kind of path to revenue attached to them. They make sense on the surface. And sometimes it could be as simple as let's improve that error message because we're getting too many support requests because people are confused, not by the problem, but like the error message is just confusing and they
Yeah.
reach out. And then you realize like, okay, so these things are fixable, but you don't want your top engineers to spend their time fixing trivial issues or implementing kind of trivial feedback. First of all, they will be unhappy and eventually quit if you keep asking them to do that. So then you ask yourself, like, did I structure my engineering team in a way that I have basically like L1, L2, L3, L4, L5
Mm.
engineers that all have kind of equal amount of volume coming their way that matches their skill? So then it becomes kind of basically human capital management optimization. And there are probably some other like angles you could look at. Like for example,
I've never thought of it that way,
it's
which is a
important
really
also to
that's great. Yeah.
I think it's also important to have a vision, and in that vision, yeah, I think it's probably related to articulating expectations, but having a discipline to say no to obviously good ideas, that probably also adds a little bit to increasing that product velocity. Like for example, at Teleport in the early days, we started hearing requests for adding support for RDP. RDP is a Linux, it's a Windows equivalent of SSH for those who are not familiar with
Sure.
Windows. And yes, it makes perfect sense because if you zoom out, if you go east of Silicon Valley, like most of the world, like the Windows is still the predominant operating system. So not supporting RDP is just strange. And we didn't have immediate customers who were willing to pay us millions of dollars for it. So like, yeah, how do you treat that feedback? It's like people say, it would be nice to have Windows, particularly when not a single person at your company is like a deep Windows level expert. So this is where vision needs to come in, where you say, we believe in such and such things. And here's our long-term roadmap. We're going to do it no matter what. Because if we don't do that, like we're not going to realize our vision.
Yeah.
And Windows was on it.
Mm.
So yes, we had to go and make that painful step, acquire deep expertise in Windows internals, like kernel and kind of and security model, and eventually become like one of the best implementations of remote access into Windows. But that I think plays a role as well, just sticking to your original vision and being disciplined about it.
That's really interesting. And has the Windows like kind of investment paid off?
Yes,
Oh, interesting.
because again, our vision, and I'm like trying not to sound like an ad for Teleport,
Hey,
but
you know,
look, I do think it's important. So here's what Teleport Business is fundamentally about.
yeah.
All the hacking that happens, at the end of the day, it's about exploiting human error. If humans were never making mistakes, it's impossible to hack into anything. So if you look at vulnerable software, let's say you're running on a vulnerable version of WordPress and someone goes through like zero-day exploit and runs code on your server, that's a human mistake. It's like someone made that mistake when they were developing like a WordPress plugin or something. Or if you get like a text message that says, hey, this is Mike, your like one of your engineers, can you please like help me? So like that's a phishing attack. They tricking you into making some kind of mistake. So you might enter your credentials into like a fake login portal so that your credentials will be stolen and they will be later used to get access to your infrastructure. So again, it's again human mistake. So, and that's ultimately, if you think of this kind of first high on, so on a high level, it's always human error. That's the first step towards a breach. So then, are they exploiting a behavioral error? So that's an identity attack. It's when they're tricking you into do something you're not supposed to, or are they exploiting a vulnerability in software that someone made? So that's a malware attack. So now we have two classes of attacks: malware and identity. So malware is much harder to do now because we have patching, we have supply chain security. So we as an industry, we're getting better and very quickly at preventing malware class of attacks. So they keep shrinking. So now over like, it depends on which report you're using, but between 75 and 85% of all attacks are identity attacks. It means that attackers using human errors, finding a way to impersonate someone's behavior, like someone or something. Okay. And there are plenty of cybersecurity products. There's a huge industry called cyber. They had this RSA security conference just happened a couple of weeks ago. And they essentially all of these solutions are trying to prevent human error, like in one particular kind of aspect. But we believe that instead of treating symptoms, we need to look at the root cause. And the root cause goes like this: how can you design your infrastructure security that it's immune to human behavior? Like there's no relation between human behavior and probability of you getting hacked. And you can even follow this logical kind of set of questions that I could be like asking you, like an imaginary security engineer. So if I say like, do you agree with me that probability of you getting hacked during this podcast is directly related to probability of one of your engineers making a mistake during this like hour? It's like, okay, it's a reasonable assumption to make. And I'm like, okay, do you think that probability is low or like too low or too high? How do you feel about their security? And it's like, well, it's low enough that I'm not worried. We have good engineers and we have like systems in place. And like, okay, but if I ask you, is that probability zero though? No one will say it's zero if they're smart.
Right.
They know that there is something stupid someone can accidentally do that will lead to you losing your customer data. Okay, so it's not zero. Now start looking at what needs to happen in order for that probability to go up. The obvious thing is, what if you hire twice as many engineers next year? Will that probability go up? Like, yes. Will it double? Probably, yeah, it will double. So you double the number of engineers, then the probability of someone making a mistake goes up, also doubles. Probability of you getting hacked doubles. Then I ask you, what happens if you grow your infrastructure? You now have like more like servers everywhere. Most people will agree that, yeah, probability will increase as well because there's just more things that mistake. Exactly. So then you start deploying more workloads onto these things. So you put like, you started life with being MySQL shop. Now you also have like MongoDB for something else. Then you add, I don't know, like Hadoop, and then you add Kubernetes, and then you add like you deploy Grafana. All of these things, they create opportunities for misconfigurations. Every single thing has its own kind of authentication, authorization. So will that increase probability of human mistake? And you will say yes. Now, let's take a look at these two curves. The curve, how quickly your startup is growing, and then the curve of the probability of human error. And it's growing faster. It's actually growing exponential. So you're growing linear, but probability of human mistake goes up exponential. So then the obvious question is, at some point, that probability will be so high that you getting hacked is basically guaranteed, right? So, which means that as you scale, so my point here is that the security and scale are extremely related. So at some point in your scaling journey, you will have to solve for your infrastructure. You need to decouple infrastructure from human behavior. When people ask me, like, is it even possible? I point, in the past, I was having trouble because like I could point like at some like companies out there that I know internally how they operate, but I cannot disclose that information, right? But like look at Apple documenting their data center design. They have this Apple PCC, private compute. They say, this is how we run our AI workloads. And that is the computing model that Teleport is trying to implement. So the basic idea is that you make it impossible to impersonate someone or something else. So let me break that down. In a typical computing environment, you want to make sure that there is no anonymity that's going on, that every piece of hardware, every human, and every piece of software, they're all accounted for. They all have IDs of some kind of identities.
Sure.
And everyone realizes that. This is why we have machine identity solutions. This is why everyone uses Okta with SSO. This is why we manage identities of laptops with like endpoint management systems. But if you manage identities, different types of identities using different vendors and different solutions, you are creating anonymity. Mm-hmm. Okta doesn't know anything about your production or staging or test servers. Like it's a completely different silo of identities. So whatever you're using for a machine identity knows absolutely nothing about your laptops. So this is why it makes it easier for attackers to exploit this anonymity that exists between different identity types. Like for example, like you have a table in a database with sensitive data. Mm-hmm. And most security people say, oh, you need to secure your database. You need to have like authentication, like the connection needs to be encrypted. But the attacker says, but I can actually attack SSH. Like I could attack Linux essentially, and I will bypass your database security. So then you have, now I need to go get solution for, SSH security to protect my Linux and whatnot. But then I say I can go through your EC2 like API through AWS. I'm going to bypass Linux, bypass database, going to get data out this way. It's like, we need to make sure we have robust security configured for our AWS. But then I was like, okay, hold on a second. You're also running Kubernetes. It also listens in the network, right? So I could go through Kubernetes API. So you need to go and close that. But I can keep going. I can say I can actually get into Jenkins. Yeah, and Jenkins has access to a database, and I could pretending to be Jenkins. I can go from there. So there are basically infinite number of access paths that exist. And that's what attackers keep trying to find creative ways to impersonate something to get in. So if you are mentally in this mode of enumerating every single access path, you will make that mistake. That's really where it comes from. So what you do instead, you need to say, just like from operating system design, you see, this is why that concept is so central to my thinking. In operating system, there is no such thing as access path. Every application, every human, they all have identities issued by the OS, and the policy is enforced when they interact. So the access, the path, how you get to that interaction doesn't matter. That is the core value of Teleport, that we say you need to have your computing environment needs to have a layer, identity layer, that knows everything about your laptops that engineers use, everything about engineers themselves, all of your servers, all of your environments are staging and production are different. They need identities. And then all the workloads that you run, like things like Kubernetes and clusters and databases and microservices you deploy and AI agents you put in there. So once you have identities for everyone in one place, then access path question goes away. Because you could simply say, only these two identities can interact together in some way or shape or form. How they establish that connection doesn't matter at all. How many intermediaries, it doesn't matter. And the second thing you have to do, you need to implement identity in a strong, it needs to be strongly implemented. What I mean by that is when you say my identity is username and password, that's not true. You just described an account. It's a record in a database that has Ev Kontsevoy, username and password, hello world. Your identity is actually me. Identity is stored in the physical world. Sometimes customers ask me, Ev, what database you guys use for storing identities? And I'm saying planet Earth, physical world, that's where your identity is stored. Your identity is a combination of your biometric. It's some kind of a PIN code or a password in your head. Yeah, knowledge. And it's a trusted platform module on the motherboard of your laptop.
Sure.
So those are physical world objects. You cannot upload a TPM. You cannot clone it.
Yeah.
So if all of your identities in your infrastructure is implemented in this strong way, so you basically got this two extremely important things. First, identity becomes non-spoofable. And second, all interactions between all identities are always enforced. Now, it doesn't matter how many servers you have, how many workloads you deploy, how many engineers you hire, your security posture will stay the same. And the interesting thing is, all tech companies bigger than certain size, they all adopted this model. This is why you don't hear China or Iran or Russia hacking into iPhones over the network. It's just not possible. Even though phones are made in China, is interesting. Like like the security model is so strong that we can actually allow the country that we're not friendly with to manufacture our hardware, and then we trust that hardware enough to run critical workloads on it. That is what we try to offer to everyone with cloud computing environments.
That's cool. I have never heard the story or the pitch in that way. So it's a very interesting way to approach it. And I'm guessing it's like, I mean, and assuming you do this by assigning, or I don't want to say, I guess managing those identities for everything, not just for, for one thing, but actually everything you
Yes,
have
yes.
identity around.
And again, the original use case was exactly that. It was Gravity. It was deploying on premise, because when you deploy a SaaS application into someone's environment, you don't know ahead of time what kind of components, what kind of workloads will be included, right? So some customers want to deploy MySQL on-prem, others want Postgres, like some want both, and then there's Kubernetes and SSH. So that is where that requirement came from, that we needed an identity system that supports every possible type of workload, and the analogy to operating system is just undeniable. So because that's how, for example, this model of computing, sometimes people call it's a trusted model of computation. So you need to make sure that your computing environments are trusted. Again, it came from operating system research. Like Linux originally didn't support it, actually. But so this is where SC Linux came from, because military, they looked at Linux and said, we want to use it, but it's not secure enough. So we need to have this kind of complete trust. And they funded, if I remember correctly, the development of SC Linux. So we see deploying software on-prem is really hard if you don't have that capability. So we built a capability, but then we found that capability is actually there is enough demand for trusted computing outside of on-prem deployments.
Interesting. It's a really great story. And just I guess, tell me how it's been going, right? Obviously once you exited the direct competitor world for me, I obviously followed along a little bit and saw that, continued to have some success, but what's it been like? How's, I'll be very honest, we had some ups and downs, right? We kind of had this big boom. We raised a ton of money in 21. Then we had to the market kind of collapsed. We had to refigure out a lot of things in 22. And it's been kind of this steady but slower growth over the last 3 years for us. How's it been for you? Have you had to, manage these similar headwinds, or have you been able to, it seems like you've been able to grow a bit better than that throughout, but how's it going overall?
So the value prop is really appealing.
Yeah.
So the rate of growth for Teleport actually is directly related to how well we can optimize this GTM. Because if you were to close a large deal, we're going to convert your computing to trusted computing model, just imagine how many buyers, buyers, how many people are going to be in the room that you need to convince, and all of them are going to be skeptical because if it's so obvious, how come we haven't done this before? So as we gradually, but the first couple of years were actually super high growth. As I said, COVID definitely helps.
Yep.
Which, by the way, always makes me feel guilty. I moved out of San Francisco, where I was surrounded by tech people. So now I live in East Bay.
Yep.
And my neighbors are from all kinds of industries. And sometimes when we you get together, you talking to these people and you say oh, COVID was great, we tripled our revenue a couple of years in a row, and you're smiling and you're holding beer in your hand, and then someone says, but my dad died during COVID, and that brings you down real quick. It's so, but it is true, COVID definitely forced the kind of SaaS industry or tech industry to look closer at their security posture. So the first couple of years for us was just amazing. Series A, Series B, Series C was also really competitive. Yeah, we became unicorn, valued at $1 billion, right, even though our revenue at the time was less than 20 million, if I remember correctly. So that was in 2020, end of 21, maybe. Yeah. But then the bubble bursted. So we ended up with interest rates that are greater than zero. Every a chief financial officer, CFO started to be involved in these deals. They need to evaluate if you bring enough value. So you start looking closer at your pricing, because up until then we didn't care about pricing. Oh, let's just make it that. Can we close these deals? Oh, sure. Let's increase it a little bit. So we were kind of cavalier about pricing. Now you start to be more disciplined. For example, when people look at solution like Teleport, they intuitively assume that we are going to charge according to how many engineers use solution. Okay. But then you look at your vision, and our vision says that infrastructure should be fully autonomous. Why do you
Mhm.
need engineers touching your production? Think about that, right?
Right.
Like, particularly if you're a wildly successful company with like million servers in production, sprinkled across multiple data centers all over the world, or cloud environments, doesn't matter. You don't want engineers to touch production. And I say that to our customers, and they sometimes, but that means you guys are going to be out of business. And I'm like, no, the value that we deliver is in identity management.
Hmm.
That every server, every process, everything you have in all these different corners of your infra globally, everything needs an identity. That's what we're going to charge you for. But that's the conversation we didn't do in the early days. So then you acquire a bunch of customers who believe that your value is directly correlated to how many engineers you have.
Mm.
So essentially, I'm saying that when macroeconomics become, when macro conditions become tougher, it forces you to actually realize, you know what, like those MBA types that we make fun of as engineers, they actually know something about like designing pricing properly, making sure that customers connect your pricing to value that they're getting
Sure.
out of your platform, communicating your value correctly. So for us, 22 and 23, those are 2 years where we had to actually go and do that
Yeah.
education. And yes, we rebuilt our GTM model, and now we're back into like the growth is now actually accelerating.
Yeah.
And again, I don't want to say that's simply macro. It was really tempting to say at the time, like you
Sure.
get in a board meeting and all of your investors say, yeah, everyone is struggling. So it's just like, oh, okay. So it means we're doing okay because everyone else is in the same boat.
Sure.
But I'm kind of proud that the leadership team at Teleport, we took that as an opportunity to examine closely if there is something we could do better. And turns out there was a lot that we could do
Mhm.
better. Again, including things like pricing, packaging, messaging, and all of that.
Yeah, it's a great point. I mean, like when the market kind of fell apart for us, we realized like we didn't even have like much data about how customers were using it. We didn't know who was really successful. It was
Yep.
like we had to like, first it was like we were like get the data. Then to your point around earlier on expectations, we were like we had been telling everyone like that our product was like the easy button, and I was like, that's bullshit. Like it's selling doing on-prem software and installing it is hard
Yeah.
as fuck. Like we need to tell people it's a hard thing to do. We make it better, but like you're gonna get an F by yourself. With us, you're gonna get like at that point, I was like, tell people they're gonna get a B. Eventually, I want them to get an A or an A plus, but like today, it's just a B, right? Like, but just set realistic expectations, and then we can exceed them later. That was like a core thing for us early on. So
But look, I kept actually following your trajectory
yeah,
because again, I believe that it needs to be done. Like eventually, in fact, I believe it's going to be a predominant model. And the one thing that I thought that you guys did that was really smart, you kind of decomposed your product into things that are kind of useful. Like essentially, it's kind of same thing that we've done with Teleport, but you went further. So my
yeah,
understanding is now Replicate is kind of multiple things that you
yep,
can combine in a way that fits you. And I do think that's probably the solution, or at least direction. That's the right direction. You could say, like, here's like 5 tools you could use to build your own on-prem deployment system, and it will be custom to you, and it will be a journey. Actually, I used to be afraid of saying that. People would say, because everyone wants the easy button, and it's so
yeah,
tempting in a sales conversation to say, yeah, you're going to get the easy button,
yeah,
and then you're going to keep your fingers crossed that it will happen. But I actually now tell people it's going to be a journey.
yeah,
Transitioning to trusted computing is not instant. You have a lot of legacy, and we have a huge roadmap, and we've already built a bunch of integrations, and we'll continue working with you. Moving forward, we are going to be your trusted computing partner. This is not one-time interaction, but not transaction. And surprisingly, like a lot of people find that appealing because they see that you're not bullshitting them. You are acknowledging the fact that there is a probability that they have, I don't know, like an application written in old version of PHP running on CentOS 6 in the corner of the basement of their giant bank, and it's making them $200 million a year, and they're afraid to touch it. And you say, and we could still secure it. But it's not going to be easy, and it's not going to be instant. It buys trust. And I do like to say that if we're like a trusted computing company, so we need to pay attention to everything trust building, including honest communication of expectations.
yeah. No, and I love that. And to your point, like one of the things that kind of decomposing parts of it do is it makes it a little bit more like a Lego kit
Yeah, yeah.
that you can, and then honestly, it's like when you're putting together Legos, you're not like, oh, the Lego people are so great. You're like, I made this, right? And so it
That's a
actually
great observation. Yeah.
it gives you a little bit more ownership of what you've made. It gives you like it's a little bit more custom to you, and it somewhat makes that person who's like that led the project a little bit of a hero, right? Which to
Yes.
your
Yeah.
point, like which is actually another thing that we've really tried to focus on is like how do you take that? Because for us, and I mean, I guess maybe to your point, I hadn't thought about this, hadn't made this connection until you said this, but like we realized that the most important person for us once the purchase has happened, and honestly, sometimes leading up to the purchase, is actually not the person who's buying it. It's not the person it's a person who's implementing it. And when we have a really sharp person who just gets it, or a couple people that just get it and they're super like they're just on it, they know
Mhm.
Kubernetes, they understand how this all goes together, they can like pull the pieces together, those customers thrive and they
Yes.
grow and they use it more and they're really successful, and we track this installation success rate metric and they're getting 95% install success or 98, and they're winning, right?
Yeah.
When they leave and they don't get replaced by someone equally good, there's like for us there's like that customer trails off, and like eventually like they're like they have a lot more support issues and they're not having a great experience, and it's because they don't have that deep subject matter expert there anymore, and maybe we lost connection when didn't build the next one and build a couple of them in there. But I didn't connect that fact that it is because it's like a Lego kit.
Yeah.
That's a
Yeah.
great point.
I was always like in the early days, I remember you guys had, I think, quote from like one of HashiCorp founders
Yeah,
on
from
your
Mitchell,
website.
yeah.
Maybe you had them as a customer, but that was like Hash's approach. Like have multiple tools
Yep.
that work really well and they do one thing really well. And I'm kind of surprised that I haven't considered this early. Like even the fact that Gravity was always abstracting teleport away. Like it was a while before we built like teleport's native command line tools. And now I wonder why we did that. Maybe because it was this kind of easy button kind of appeal. Yeah, there's a lesson here somewhere. Like, when do you go for an easy button? Because maybe sometimes it is actually the right way to do it. And when do you expose complexity to a customer and just become open and honest with them that we're going to help you to deal with complexity, but complexity is there.
Yeah, and maybe now we're gonna get into the AI thing a little bit. Like maybe now with AI, it's like that's going to be an assistant in helping them kind of manage complexity and pull these things together a little bit easier. And yeah, I don't know.
So I have this. It's kind of interesting that I was starting to think about AI like about like 2 seconds before you said it out loud, and also I feel this urgent need to apologize to the listeners because I
Yeah,
believe
yeah,
all of us are suffering from AI fatigue at this point. Everyone is talking about AI everywhere, but when we talk about at the end of the day, like things like Gravity are replicated. Like there are tools. Like I really like your analogy with Lego like blocks that engineers could use to like assemble their own solutions. And when AI comes into play, what I maybe it's me kind of crying and not exactly for help, but I do want like new generation of entrepreneurs to think about like a few considerations. So there are a lot of AI companies today that are launching and actually pretty successful. They try to make AI solutions that reuse the tools we already have. What I mean by that is look at, for example, all these like machine coding companies that help
hmm
you generate code. But what is the code itself is a tool, like programming language is a tool. So it
sure.
was invented to help convert from English to assembly language of a platform you're running on. Okay.
hmm
But even assembly language is also a tool that helps you convert from like really kind of limited, like a really small kind of formal system of symbols into a machine code. So that's
hmm
another level of translation. And why? Because humans are terrible at thinking in machine code.
Sure.
Even though I learned x86 assembly language when I was in high school, and I was really proud of it at the time, I never bothered with machine code. It was just like crazy.
Sure.
Now ask yourself, like, why do we need all these intermediate steps today in the era of AI? Why can't you then have a machine? Like, can we have a new generation of programming language that is designed specifically for AI to be the one that's doing the programming? And how would it look like? Would it be different? And I was experimenting with generating, essentially using AI to generate binaries directly. So that is
Mm-hmm.
they cannot do that, but you can generate an assembly language, and then you
Mm-hmm.
can even do like a fun experiments. So you could come up with like a fun project and ask AI to write you, like C plus or C or Python code, whatever. In my case, I was playing with C, and I was generating like a little application, and then I would like compile it and then see how it runs. But then I will work my ass off trying to get the exact same thing done in assembly language, basically trying to talk
Mm.
into an LLM. And I tried like all of them. And then eventually, yeah, you can have LLM generate an assembly that is actually way more efficient than assembly generated from C by a compiler.
Mm.
All right.
Interesting.
So then you're asking yourself, what's the value then of having compilers and like languages like Python and C++? And the people will say like, well, because the code that AI generates, like it needs like human review because it's probably going to be not optimal. Like AI like hallucinates and all of that. And I'm thinking, is that going to be like that forever?
Right.
If we all agree that like the rate of improvement of models is actually impressive and they're going to get better and better, so why are we clinging to use these kind of human readable old school programming languages? And then if you think about this for a while, it's kind of a fun topic to have over beers at the bar with your programming friends. But it actually applies to everything. Like look at the browser, like we both of us are staring at.
Yeah.
Like we have Slack and we have all these different buttons, all the different everything is designed for humans. That was the user it was built for. So then the next question is, what would be equivalent of all of these things built for AI? And that's kind of little, almost like a hobby of mine that I keep looking for, like AI startups, AI announcements, or even just ideas, or even like comments on Hacker News
Yeah.
that describe the tools that we need to build for AI. So that's kind of where my obsession with AI currently lives. Because like a lot of things, they stop making little, like for example, and look, if I'm talking too much about it and we want
No,
to
no, it's
move
great.
on,
It's great. I love
let
it.
me
I
know.
love it. I was thinking about it.
Okay,
Sorry.
so think about the concept of a software library. So we have all these languages with libraries included. Like you have Python that has huge standard library. Golang has libraries for encryption and making HTTP requests and all of that. Like the libraries exist so that we don't have to re-implement these things from scratch because it takes
Sure.
time and humans are expensive. But if AI can do it, why do you need libraries then?
Yeah, I thought I had the
You
same
could
thought.
have
Yeah.
a AI generate the whole freaking thing from scratch
Yeah.
with no dependencies whatsoever.
Yeah.
And again, I tried that and it worked really well.
Mm.
And so essentially, your entire kind of program then becomes basically a series of prompts. Because, like in my case, the little project I did just for fun, that I used, I think it was Gemini maybe, to make a library that parses EXIF metadata of digital images. You could see like aperture and the camera model and the lens and like whatnot. And it generated me this thing using like in assembly, and it was highly optimized. I was like giving it hints, like like can you use these instructions of those instructions, and then once you have it, like you don't need there is no need to have EXIF library anymore because it can regenerate it again and again. Again, it's not usable in production today, but because technology is new, like
Right.
that's one thing you learn about tech, that it gets massively better very quickly. So then it looks like we no longer need these libraries like in the future. So that's what I'm excited about. AI native tools that are made to be used by AI.
Yeah. So it's funny. I like that you're going to try to solve it because I feel like I can't reason about how they actually work yet. Like what's happening underneath the hood, like some non-deterministic, way of like, I'm like, I don't know. I struggle with like how they actually come up with these things. Right.
Yeah, but do you struggle with not understanding what's happening inside of your compiler when
That's
you
true. Yeah.
like
Yeah.
using
Yeah.
programming languages? And
Or
people
even
say, "Oh,
what's
it's
in what
deterministic."
happens inside my head even. Oh
Yeah,
yeah.
it generates the same code all the time. Like, no, it's
Yeah.
not true.
Yeah.
Actually, like Golang, like the last language that I've been coding a lot in is Golang. And look, compilers went through dramatic transformation from like version 1 to where it is today. It's gotten like
Mm.
it learned to do new types of optimizations, and look, we're comfortable because we trust it.
Yeah.
So eventually, once the models they get into that same state where we don't care about black box anymore, it's going to be the same thing. And then you will ask yourself, why do I even need to stare add this kind of C plus or Golang code generated by the thing. Just give me a binary.
Yeah.
But
No, I agree with that. I agree with the future. I'm just saying, like, I struggle with actually trying to figure out like what the AI native tooling will be, because I think I'm like, yeah, I mean, I understand what they talk about in terms of like how we train these things and how this stuff, what's it retrieving, and maybe it's like a compression thing, but I feel like I don't understand it well enough to like build a tool for it, right? It's like I don't know my user well enough, right? Like it's like I can't get, it's like I want to like get in the mind of my user. I want to observe my
yeah,
user. I want to
yeah,
like,
yeah.
I want to have the, it's like, and I just don't, I struggle with being like, oh yeah, I can like, deliver something that this thing actually is going to be great at using. So
I think what you're struggling with is so let's call it like the difficult middle. It's really
mm,
easy to dream about this beautiful world in the future we're going to be in. And then it's really easy to recognize the limitations of the present. But it's the stuff in the middle that's so freaking hard to figure out, particularly
yeah,
the sequence of it. Oh, first this needs to happen and that this needs to happen. Yeah, that's just really tough. I struggle with this too.
yeah, that's a great point. You're like the broad vision, and then that like, how do we get from here to there? Like, how do we, how do we go there?
Yeah. So the one AI topic that I do believe that I should say a few things about, because so that's our area of expertise, is that when companies now starting to deploy AI into their data centers,
Mm-hmm.
and I'm hesitating to use the word AI agent because there are two different kind of meanings
Sure.
people have. Some people believe that AI agent is something that runs kind of like your co-pilot on your desktop that's kind of helping you to kind of interact with different applications and websites and whatnot. So that's an AI agent. And some other people that think that AI agent is essentially like LLM running like as a microservice in Kubernetes and is processing requests and producing inputs and outputs. So I'm speaking about the kind of server side AI. So right now, there are plenty of companies that are deploying those things or trying to deploy them in production. And the interesting thing about AI is that it's vulnerable to both types of attacks at the same time. Remember, we talked about at
Yeah.
the beginning of the conversation that there are malware attacks, that
Mm-hmm.
your microservice implementation might have a vulnerability. And also there are behavioral attacks, identity attacks, and AI is vulnerable to both.
Mm.
So it's like there could be like basically a 0-day exploit that I could just exploit as an attacker, or it could convince your agent to do something it's not supposed to. There was a funny story actually a few weeks ago. I wish I remember more details about it because I read about it, kind of laughed and moved on. Now I realize I should have maybe like saved that announcement. So there was some kind of company that exposed like LLM publicly and they said like you can interact with your checking account with your bank via this model, and we made it so secure like you will never be able to get any money out of it, and if you do you can keep the money. I believe they put like $50,000
Okay.
into checking account in 30 minutes. I think it was wired out. So the attacker convinced it reframed the meaning of it, kind of swapped the direction of like the LLM was thinking that it was wiring money in, but in
Okay.
reality it wired it out.
Yeah.
Like I wish I remember the details. Like it was really cool. So the question is, how do you secure these things?
Yeah.
So you have an LLM running, and ideally, you want to enable it to have real time runtime access to all the data sources you have, because you want that LLM to be useful to you.
Sure.
So the more data you give it, the more utility you extract out of that investment. But at the same time, you don't want that model to have like when that model interacts with different people, it needs to be guardrailed, right? So, for example, if I talk to an LLM and I ask, "Hey, how much my like peer makes over there," and if it had access to like HR database, like that obviously is not an information you want
Sure. Yeah.
to disclose. But if the head of HR is asking the question, like print me a table of like top compensated salespeople we have, for example, it should respond to that. So there is a kind of debate now happening in cybersecurity circles. How do you actually solve this problem? And I do want to share our view because I feel strongly about it. And again, I don't want to sound like a teleport ad, but our view is that LLMs, they need to be treated exact same way as humans and machines and laptops and everything else. Because there is a great temptation that currently exists, particularly in kind of startup ecosystem, or LLM is a new thing. We need to come up with like LLM identity, and we need to have LLM authorization and LLM authentication, LLM audit, and kind of AI versions of things that we've built for humans before. And I think it's tempting from kind of investment perspective. Like if I'm a VC, like, yeah, I should like invest into this AI companies that are trying to secure AI. But AI, we believe, needs to be incorporated into this kind of operating system concept that it's just same identity as humans, machines, laptops, applications, microservices, because otherwise you're gonna end up with another silo, and then it will be impossible to tell. Like impersonation again becomes possible, identity spoofing becomes possible. So that's our strong view. So we actually announcing now secure support for MCP. So MCP is the protocol that
Sure.
AI is using, or more and more. It's a standard protocol that we want, not we as Teleport, but I think like Google, Anthropic, and OpenAI, they're all
Yeah.
investing into MCP adoption, that it needs to be used by AI agents to interact with data sources or with each other. And so we just launched the secure implementation of it. I think we're probably the only vendor right now who takes it seriously. But the whole point there is that like AI identity is the same identity as everything else you have. Because if we don't do it properly, I am very much concerned that
The
there's
the
just not going to be a good outcome.
the one thing that I would say that is maybe a nuance here is I feel like AI permissions need to be far more dynamic in terms of what I actually have permission for, right? So like,
Yes.
and that system needs to be external, like to your point, like the AI should not be able to like be like, oh, I need to change my permission, right? Like there should be some deterministic system.
Yeah, like there are basically two things there. So first of all, like your AI should not be assuming your permissions, because that's just not
Right.
fair, right? Because you don't want to see your name in audits where like an AI agent that you launched, they did something on your behalf. But the really important realization, even before we talk about AI, is that in access control theory, there are kind of two predominant models that exist. There is role-based access control and
Mhm.
attribute-based access control.
Mm.
So the difference is that, like, we all know how RBAC works. Like,
Sure.
pretty much every engineer had to deal with, like, am I in the, like, do I have administrator role, or do I have, like, a regular user role and whatnot? But attribute-based access control is simpler. So when there is some kind of interaction between two subjects, and access control theory is basically about interaction of subjects. That's basically identities, humans, machines, applications, and objects and data.
Right.
So when subjects are trying to access objects, you just check certain attributes in real time in the moment when it was happening. So let's just say, for example, you want to do deployment in the organization. And what kind of attributes could be checked to determine whether you have permissions to do that or not? Like, I would argue that a really good signal is if there is a ticket created, like in Jira, or like whatever you use to create like a deployment ticket. So there's a digital artifact that says you need to go and do this unit of work, complete deployment. So then you give permission to, like, Ev, for example, because I'm assigned to that ticket. So that's an attribute. And also you issue permissions, for example, to Jenkins, because they're going to do deployment using Jenkins. So, and you make sure that I'm not on vacation, and you can make sure that I'm using company issued laptop. You could check like arbitrary number of attributes. And if they're all set in a certain way, then the access is granted. But then when you complete that unit of work, the ticket is closed, all of that evaporates. You go back to kind of empty state. It's really important. This approach is much more scalable than roles, because roles are static. They never change. And the
Right.
interesting thing is that every customer we have that I talk to, they all have more roles than they have employees. Think about that. Like, our back is completely broken. Unless you're like a car dealership, like, it will work for you. But if you're anything bigger than that, you need to move away gradually from role-based access control everywhere. So now we come to AI, and you correctly pointed out, if you try to plug an AI agent into this kind of static role-based access control world, you
Right.
are going to have a very hard time, because AI is a really dynamic thing.
Right.
So in certain contexts, it needs to behave like CEO of the company. Like, for example, it's trying to generate like a panel statement, right?
Right.
And in some other contexts, it needs to be an intern. This is maybe when you want to check what's the holiday schedule like we have. So you need then to guardrail that model based on probably who it is talking to, or what kind of like the nature of a request.
Yeah.
You can't even answer that question. So this is why adopting attribute-based access control for AI is going to be absolutely critical.
That's really interesting. I don't think I've ever even heard of attribute, based authentication or authorization.
Authorization,
Yeah, that's very interesting because to your point, like it is, we need something more dynamic, and so if that's what it is, that's a really interesting approach to it. Is teleport, is that part of the platform, or is that part of the vision?
We have to support both. So
Yeah,
you have to support RBAC simply
yeah.
because you're integrating with things that are like RBAC is how they already
That's what everybody does.
configured.
Yeah, that's the world. Yeah,
And then we do have ABAC capability via access requests that we like evangelizing. So in this kind of happy end state, you need to have ABAC, just in time ABAC. Maybe it's worth
exactly.
explaining maybe in a better detail that today, even pretty much at any company, if you look at what's happening in their infrastructure, you will make a very obvious observation that 99.999% of the time, there's no need to access anything. Servers are working, processing transactions, making you money, things are fine. It's really like when there's something to change, that's where humans need to be involved. So therefore, you need to take a look at the timeline, and you could say, this is my steady state where there's no change happening, and this is when change is happening. And then you need to take the steady state out of your mind completely. You need to say, in a steady state, my infrastructure is not accessible. So how do you enforce that? You say, I have no users. Like all of my servers are clean. They have no users on them. They have no roles, no groups. Same thing for Kubernetes, same thing for MongoDB. Like everything is like squeaky clean. Like they're not even like, there are no accounts anywhere. Like even theoretically, no one can access it.
Right.
Wouldn't that be wonderful if you could say that I don't have to think about it? Basically, it means you can go to sleep every night without being like, without afraid of someone breaking something.
Yeah.
And you only create, so then you need to create user accounts on these things, and you need to issue them privileges according to what change needs to happen. And now it becomes much simpler because you're not deploying things 24/7. You're only doing it maybe like twice, maybe 3 times a day. So then you create privileges and you assign identities to a unit of work. And then when unit of work is completed, like deployment happened, like backup job like was started, whatnot. So when it's done, the ticket is closed and you go back to steady state. That's much, much simpler and therefore much more scalable access control kind of method that using static role-based access that exists all the time. And this one is much friendlier to AI.
Yeah, for sure.
Because you can create like essentially every conversation an agent has with someone or like from the outside world, you can then guardrail around that particular context for that conversation, which is really hard using roles. Hard to do using roles.
No, that makes a lot of sense. That's a very interesting approach and perspective on it, and it honestly seems very relevant because again, I'm like RBAC, long-lived RBAC for an agent. It's like no, it can't have all access to everything that it needs to have access to. Sometimes it needs all that access, and then other times it needs minimal access. So that's cool. I'm glad that there's people out there solving that problem because I think it's going to be a very large opportunity for you. So that's cool.
Again, we need to give credit to people who invented all of this stuff, and it goes back to like 60s and 70s and 80s.
Yeah.
Again, it's not exactly new. We actually published a book last year about it. It's called Identity Native Infrastructure Access Management. I know it sounds really boring, but there is a kind of short history lesson there too, like where all these concepts came from. So when we bring people into teleports during onboarding, we cover like Multics operating system, like one of the original operating systems. And we use that as a kind of vehicle to describe kind of fundamental concepts of access control. So the point is, like in academia, we solved these problems many years ago. We just need to modernize it and scale it up and make it accessible to AI and to other forms of modern workloads that we're deploying in production.
I also love that as like a source for kind of like inspiration to modern problems is like look to the kind of the original, like answers from academia or computer science or, like how do we, it's like to your point, the operating system has probably solved this 30 years ago. How do we apply that more broadly? So I think it's a really good paradigm to look at these problems from. So
Yeah, like I think of like what would operating system now even mean if you have so back in the day it was designed for applications and for humans. So there were kind of two subject types. Like, shall we treat AI as yet another? And if that's true, what changes to the operating system do we need to introduce?
yeah,
Which is kind of related too to this like earlier conversation we had about changing our tools to account for AI being yet another user. So
right.
because operating system at the end of the day is also just a tool.
Yeah, that's a good point. I know you got a hard stop, so I wanted to give you a moment to wrap up. But Ev, this was super fun. This is so the listeners can know the first real like deep conversation we've had, right? So,
Yeah, I
after
really enjoyed
yeah, it's
it.
really fun. I'm looking forward to a dinner or something in the not too distant future.
Let me know when you're in the Bay Area. Looking forward to it.
Awesome. Thank you, Ev.
All right. Thank you. Bye.